Hi, I'm Don Nicholson from Elevate, and if you are anything like me, I've always been fascinated at the processes that bring a product to market. So we wanted to give you a behind-the-scenes look at the manufacturing of our Performance Inlet Manifold. In manufacturing our Performance Inlet Manifold, we partnered with some of the best companies in the industry to produce a top-quality product. Since all of these companies are local to us here in California, we took the opportunity to film many of the significant steps that go into manufacturing this part. I hope you find this video interesting and gain an appreciation as to the effort it takes to offer this item to Volvo and Ford enthusiasts around the world. This is the show core box. It makes the show core, which is used in creating the void inside the inlet manifold. The show core box is heated to over 500 degrees Fahrenheit with gas burners. With the show core box halves joined, sand is pressure fed into the hot show core box. The sand bakes and becomes hard as it comes in contact with the hot aluminum mold. Excess sand pours out of the inside of the show core. Heat is applied to the inside of the show core to bake the sand and seal the end of the show core. The core box halves are separated and the show core is removed. Again, it is this shell core that creates the empty void inside of the Performance Inlet manifold. This process is repeated to make the next shell core. Here, the craftsman trims the flashing and refines the core to ensure smoothness. The smoothness of the outside of the shell core determines how smooth the inside of our inlet manifold is. This is the pattern match plate. It is crafted out of aluminum. The match plate is what forms the sand to create the exterior of our Performance Inlet manifold. The match plate is inserted into a box and sand is hard packed to create the bottom or drag half of the mold. A sand mixture is fed from an overhead hopper to fill the box. The box assembly is shaken to pack the sand. The sand is hard packed using a pneumatic gun on the packing table. box is flipped over, exposing the top side of the match plate, which is called the cope. The cope side of the mold is then hard packed with sand. A pour head is pressed into the mold. This creates a passage for the molten aluminum to be poured into the mold. The mold undergoes one final pressing to pack the sand densely. The pouring head is removed, leaving a passage for the aluminum to flow into the mold. Pressurized air is used to blow excess sand away. Pressurized air separates the two mold halves, and the top half of the mold is removed. The match plate is removed and ready to make the next mold. The bottom half of the mold, the drag, is placed on a rolling conveyor. Water is sprayed onto the sand mold impressions. The shell core that was previously made is placed into the mold. Positioning references are built into both the mold and the core for perfect alignment. The white tabs on top of the shell core ensure uniform wall thickness for the part. The top half of the mold is put into place. The void between the sand impression and the shell core is where the molten aluminum will flow. The box is released and readied for making the next mold. The mold is jacketed to ensure no molten aluminum runs out between the mold halves. Here, aluminum ingots are added to the pot. The temperature is over 1,325 degrees Fahrenheit. Molten aluminum is poured into the sand mold. The casting is allowed to cool, and then the sand mold is broken away from the performance inlet manifold. Part of the molding process is to allow gating, where the aluminum can flow into and through the mold during the casting process. This ensures that no air pockets are created. The gating also allows for handling of the new casting without affecting the finished part. The next process is to break up the shell core. A pneumatic jackhammer is applied to the gating to vibrate and break up the shell core inside the performance inlet manifold. Next, a bandsaw is used to cut off the excess gating material. Here, the craftsman uses a belt sander to smooth the surface and prepare the casting for the machining process. There are 3 operations in the machining process. The first is to machine the surface and precision cut the outlet ports. CNC machining creates precision dimensions. By CNC machining the outlet ports, our inlet manifold matches the stock lower manifold perfectly for increased flow and performance. The second machining operation, not shown here, is machining the surface where the throttle body attaches to our inlet manifold. The final machining operation is milling the Elevate logo on the top of the inlet manifold. After all CNC machining operations are performed, vacuum ports are drilled and tapped and fittings are installed. The inlet manifolds are then powder coated in black or bright silver. Our inlet manifold uses a custom designed gasket instead of the factory O-rings. This allows us to have larger outlet ports that flow optimally. Top quality gasket material is precision cut and later coated to create our gaskets. Before shipping, every one of our inlet manifolds are fixtured and pressure tested to over 50 psi or 3.4 bar. This ensures that everything seals correctly and proves burst resistance under high boost pressure. The very final step is our customers installing our performance inlet manifold and enjoying the great looks and power gains that it provides.